Hello everyone. Today we are going to build a low-pass filter. In the last lectures, we have built a voltage divider. What we are going to do today is to turn this voltage divider into a passive low-pass filter. To do this, we need to build a capacitor first. So I create a new cell capacitor, and the capacitance is around 100 femtofarads. In integrated circuits, it is very difficult to come up with a big capacitance. The capacitance is proportional to the surface area. If you want to build a capacitance of around 1 nanofarads, then the capacitance will occupy a very large area. So to begin with, we are going to build the schematic first, and the first the capacitor will be formed by a polysilicon 1 layer and a polysilicon 2 layer, P1 and P2, and the capacitance is 1 femtofarad. And this capacitor has a pin at the output and another pin at the input, and then connect the wire. And like this. This pin is called P1. This pin is called P2. And we have to clean up the design. And now we are going to check whether we have violated any design rule check. Apparently everything's okay now. Now the next thing we are going to do is to build a symbol. In Electric VLSI, a symbol is called icon. So to start with, we are going to go to the View tabs and then make an icon view. Now this is so-called the icon for the capacitor. It's very lousy. We don't like it. So the next thing we are going to do is to go into the icon view of these cells, and we edit it. Now this is the capacitor. We don't like this, and we cut this. Now we just do some positioning. And the easiest way to form a symbol of the capacitor is to just use the symbol in the library, in the schematic library. And for this one we are going to rotate it. And this one we are also trying to rotate. Now we are going to move it to here. You see, right? It's apparently too long. Now the symbol is done. So this is the schematic. This is the symbol for this schematic. Apparently, the value of the capacitor should be 100 femtos. Everything okay? Now the next step is to create the layout. Before doing anything, right, we also need to check the DRC track. Now we are going to create the layout for this capacitor. And our technology is mode CMOS. What we are going to do now is to this is a very tricky process. I have to warn you. You cannot just place two layers together and then claim this is a capacitor. This software is very strict on the connectivities. So what we can do now is to just place the pin. In this case, I'm going to place metal to polysilicon 2 contacts. And I'm going to widen it. It's going to be 150. So now you can create a layer by drawing a polysilicon track from this pin arrays, this contacts array. Left click first to select the pins, and then press the right button of your mouse and drag it across. Now I got the polysilicon 2 layers. This side is about right. And I also need to create a pin, a contact array. The contacts also have the same width. So it's about right now. And now I need to draw another polysilicon 2 track. This is polysilicon 2. What we have just done, is polysilicon 1. Okay, now is polysilicon 2. Select the pins array and then create a layer. So this is the two layers of the capacitor. We are going to make a capacitor. By doing this. The total capacitance will be dependent on the overlapping area between these two polysilicon layers. Before going on further, I want to check the DRC check. Apparently everything is okay now. I have no error. Now, so this is polysilicon 2. I want to create a plane. Here the plane should be P2. P2. Yeah, again, right? You have to create you have to select the pin here. The pin here is so small. Now it's done now. And I'm going to do the same for pin 1. Again, select the pin array first. Now and only this one, and then metal one. So this is the metal contact. And I'm going to call this pin P1. Now basically everything is done now, and I'm going to do a final DRC checks. Everything is okay. The next thing I'm going to do is to simulate this capacitor. Actually, I don't need to do that. I need to do network consistency check. Network consistency checks. It looks okay. Now the next thing I'm going to do is to insert some spike hooks into the schematic here, into the icon here, so that every time when you place the icons into another schematics, then the spike hooks will take care of the sub-circuits. We go to the components and schematic, and then miscellaneous and spike hook. The spike hook should be C1, P1 and P2, 100 femtofarads. And then I also need to attach the parasitic capacitor. C2, P2 is nearest to the substrate, and there is a substrate capacitor around 10 femtofarads. Now everything should be done now. Now I have already created a cell so-called cap underscore 100F, which stands for capacitor 100 femtofarads. The next thing I'm going to do is to open the schematic of the voltage divider, which we have done in the last lectures. And I'm going to modify these circuits, but I'm not going to modify on this right away. Instead, I'm going to create another copy duplicate, and I call this low pass filter. So this low pass filter is basically the same thing. It's this low pass filter. Now what I'm going to do is to add the capacitor here. And in the component tabs, I have brought up a product menu for the schematics, and then I go into the miscellaneous options, and sorry, I shouldn't say that. I should go to the cell options. Here I got a capacitor which I have just created. So this is the capacitor, and So this is the pins to be connected to the output, and this is another pin to be connected to the ground. And before doing any other checks, make sure I have done the cleanup. Now basically this is the capacitor. Let's do some DRC check first. Yes, everything is okay. Now to check the functionality of this so-called low-pass filter, the easiest thing I can do is to modify this bytecode. I would do AC analysis, and then DEC, which stands for decades. The frequency is going to start from 1 Hz to 1 GHz. The voltage is to be applied from to V-in, the V-in pins, but it's AC. Say the amplitude of the AC signal is 1 volts. Now first of all, I'm going to check the simulations. The AC command expect the stop frequency. Okay, we got something wrong. We have to define how many simulation points we have per decade. In this instance, I will use 100, and then do the simulations. So now I've got the simulation results. Indeed, this is a low-pass filter with the cutoff frequency at 100 MHz. Okay, that's done. I'm going to take care of the layout. Now this is the original layout for the voltage divider. What I'm going to do is to add a capacitor here to turn this device into a low-pass filter. Now the next step is to go into the component tabs, and then go to cell, and I have a layout cap 100 femtofarads. I'm going to add this capacitor, the layout view of this capacitor, into the layout here. Now you cannot see anything because this is the layout view, but you can zoom it. So this is the layout for the capacitor. I'm going to use this, cut it, and then I'm going to cut this as well, and I'm going to create a track to it. Now that's done, but this metal track is a little bit too large, so I will just use 50, and I don't need any decoration and the end of the track. It looks okay. Not okay. Don't need this track. Should be like this. Yeah, I need to do it again. Okay. And we don't need any ending for this one. Everything should be okay now. And this pin is going to be called GND. Let's do the DLC check first. So far so good. Now the next thing I'm going to do is to create a metal track from here and here. Again, I don't need any ending, neither. And again, I don't need any ending. And 100 will be enough. Perhaps I don't even need this. Let's see. The DLC track is also okay for these circuits. Now I'm going to do the simulations. Perhaps the spice stack from the schematic should be good enough. Now I'm going to enlarge these spice stacks to say 30. And the old stack is useless. Let's see if I got the same simulation results. Empty. It's empty. Let's check what's wrong with this. Looks okay. In the layout view, I also need this. Let's check it again. Now here we go. And apparently I also need to define the pins D and D. And I'm going to do this again. Yeah, it looks okay now. The next thing I'm going to do is to do the network consistency check. To do this, I just need to do. Now I have a lot of error. Let's check what kind of error I have. Okay, everything is okay. There's no error. Everything is done. So now this is the low pass filter.